Hello everyone, welcome back to this channel. From today onwards, we will start working on a machine learning project. Okay, now first let me tell you about the project. It's like in an organization, employees are suddenly leaving. So they want to know the reason behind their leaving. So they have hired you. Now your job is to find the reasons why employees are leaving. They provide you the data. Now your job is to find the reason, to find the hidden patterns from the dataset. And HR can take actions accordingly. Okay, now let's start the project. Okay, now I will do this project in Google Colab. First, we will do the project, then we will write the complete documentation. Next, we will upload this in GitHub so that you can share it with your recruiters as well. Okay, now let me show you. First, from clicking here, you have to just upload the dataset. I have my dataset in my downloads, like dataset for employee retention. It has been uploaded. Okay, let's start the project now. I'll write the steps also. First, I have to import the libraries. I am expecting that you know about the basics of Python and you have also idea about the machine learning algorithms. Otherwise, it is not possible. Okay, so import the libraries. Okay, let me first do that. Import numpy as np. What is NP? NP is the nickname of NumPy. You can give anything. What is NumPy? NumPy is the library. Import pandas as video. While doing the project, I will ask you many questions. So be ready to answer those. Okay. See, it has been executed. But I have to import many other things, but I will not import right now because I want to I import all those libraries when they will be needed so that they become clear to you that why we are importing those libraries. Okay. Next line. First, we have to upload the data set. How can I do it? df equal to pd dot. You try to say if you know csv. If you don't understand anything, please write in comment section. Okay. Now I have to give the file path. From here, just click on this, copy path, paste it, run it. See. Now let's check the data set. See how to check. df dot head. How many rows it will show? You can say by default it will show 5, 0, 1, 2, 3, 4. But if you give something else like 10, it will show you 10 rows from 0 to 9. Okay, so by default it shows 5. Otherwise, if you give any number, it will show that number of rows. Okay, see. Now, first you have to know about the dataset very well. First column is about satisfaction level of the employees. Okay, last evaluation, work performance, number of project, someone has worked in 2, someone has worked in 5 projects. This is the average monthly hours they have spent. Now for 3 years someone is staying, for 6 years, 4 years time spent. Work accident, is there any work accident? Is anyone has left? What is the promotion in last 5 years? In which department they are working? And whether their salary is low or medium is high. So we have all this data with us. Now our job is to find the reason behind their resignation. Fine. Okay. Now explore the dataset more by giving df dot shape. It will show us the number of rows and columns. This many rows we have and this many columns. Okay, let me first show you the data set also. See, this is the data set. This is what we have just seen. It's about the details of the employees. Okay, here you can just check this many. Just see, almost 15,000. Okay, so we have all this data. This is our CSV file. We have uploaded this file in our Google Colab and now we are just checking it. Okay, so here I have just seen it, how many rows and columns it contains. Now let's check df.info because we need to explore the dataset. See, here you can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 columns. Here also we have seen 10 columns. And also we have to check whether there is any null value or not. See, there is no null value. If there is any null value means missing value. If there is any missing value, then either we will try to fill it with some other values. That also depends on some methods, or we can simply delete those. But here it's kind of clear there is no null value. Okay, fine. So what are the steps we have done? Write the steps as well. Second step, we have to import the dataset. Third step, we have to explore the dataset, and that means we have to clean the dataset also. After we are done with the project, we will write comments about all these things also. Okay, so that if anybody sees your project, they can understand what is there inside the project. Okay, what is the project all about? Fine. Now we have to clean the dataset. Okay, just check df dot describe. Tell me what will be the output. See here, it shows you the statistics of the dataset. Like count, total how many, number of rows, mean, what is the mean value of the column, what is the standard deviation, what is the minimum value, percentile, 25, 50%, 75%, and what is the maximum value of that column. Okay, clear? So df.describe provides you the statistics of the dataset. Now tell me one thing. Here while writing save, I have not given any bracket, but while writing info, I have given a bracket. Why is that so? The interviewer may ask you a question. Do you know what is the reason behind it? Try to find. If you don't know, I will tell you later. Okay. Now see. Add. Now first check the column names. df.columns will show you the column name. See, satisfaction level, last evaluation, number of project, average monthly hours. Now here it is starting with a capital letter, but it is starting with a small letter. Here there is a spelling mistake. There is also a spelling mistake. So we will just make all these things correct. Now rename the columns by writing df dot rename columns equal to uh, second bracket. Okay. Now inside that, this one I want to make it in small. So satisfaction level. This way, satisfaction level will be simply renamed to this. This one will be removed to this one. Okay. Now, last evaluation. This one also we can change. So we can write last evaluation. Last evaluation. Make it small. Okay. Next, anything else you want to change? Number, project, average. This is a spelling mistake, so I can change it. Like column average monthly hours. Okay. Next, anything else you want to change? This one is a spelling mistake, so I want to change this to work accident colon work accident. This will be WORK. Fine. Anything else you want to change? Department. Okay. So just write department, department. Make it a small d. Fine. Now run it. Oh, okay. It's just a syntax error. I have not closed it. I think now it is. Now it must be fine. Now let me show you. Fine. See, this has been changed. Satisfaction level, last evaluation, number project, average monthly hours, time spent, left, years. Okay, fine. Now let's check whether they have changed or not. Okay, now see one thing. When it is showing you the output, that means it is run in temporary level, but the actual dataset is not set. Actual dataset is not changed. Let me show you. If I write df, then see what happens. See, it is not changed here. Nothing is changed. Okay, so this means it is changed temporarily. It has not affected the real dataset. So we have to write df equals to df dot rename. Now see, there is no output. That means it is done. Now let me run this one. See, this one has changed. So we can just check using columns also. See, satisfaction level, last evaluation, time spent company, work accident, left. Oh, department has not changed. We forgot to do that. Department. Yes, that's why. Okay, let me write this one too. Oh, sorry, made a mistake here. That's why it has not worked. Now I think it is fine. Let me show you here. Fine. Now we have just seen that there is no null values, but still we will check. df dot is na dot sum. Now see, this will show us that 0. That means there is no null value. Okay. No, we have checked because all the rows were filled up, so there was no null value. But if you want to check it by coding, you should do it by this way. Okay. Now check if there is any duplicated values because there may contain some duplicated values. So that may create a bias. So we will check by df dot duplicated dot sum. See, this many rows are duplicated. So we have to just simply remove this. Otherwise, they will create a problem. How to remove? df dot drop underscore duplicates if equals to first. Okay, now let me run this one. Just write this again like this one to check if there is any duplicated value or not. See here, number of rows has reduced. Previously it was 14,000, now it is 11,000. So almost 3,000 rows have deleted and there are almost 3,000 duplicated rows. Okay, so it has worked. But see here it is again showing that there is 3008 values. Why is that so? Because this change is for temporary. So to make it permanent, we have to write df equal to df.drop. Always make sure that when you change something permanently, that means when you change something in the data set, then output will not be shown. Simple. If output is shown, that means this is for temporary, for your visibility only. It has not impacted the old data set. Now here df.duplicated.sum, check 0. Clear? Now tell me why I have written keep equals to first. This is because so that you don't delete all the rows. There are 4 rows and if you delete all the rows then the data will be deleted. So you have to keep one data, the first data, and you want to delete the other 3 rows. Clear? So that's why I have written keep first. If there are more than one rows containing the same data, then the first row will be kept and the second rows will be simply deleted. Clear? So as of now, what are the steps we have done? Let's write them. First, import the libraries. We have imported. Next, we have imported the dataset. Now here we are exploring the dataset. We have cleaned df.info, df.describe, df.columns. We have renamed the columns. We have checked whether any missing value or not. These are all in part 3 only. See here, like checked for missing values. Second, check for duplicated values. Sorry, before that we did renamed the columns, not all the columns, the necessary columns, checked for duplicated values and deleted the duplicated, sorry, duplicated values. Okay, so as of now we have done all these things. Later on we will explore how to visualize the data. Okay, so we will do the next part in our later video. Okay, bye, happy learning. Welcome back to our project. Till now we have removed the duplicates from the dataset. Now we will check for the outliers. Do you know what is outliers? Outlier means those data which are extreme. Suppose if I write df dot head, it will show us the first 5 rows. Okay. Now let's say that Average people work in the company for 2 to 7 years. Okay, maybe maximum 4 to 5 years. But what happens if there is someone who is working for 15 years or someone who has left within 1 month or 2 months? Then these data are extreme. These are not average. These are exceptional. These are kind of far from the average. So we can call this data as outliers. So now our target is to see how many outliers are present in our data set. Okay. Now how can we do that? So we have to write plot dot figure fig size equals to 6 comma 6. Now see here it is showing as underline because I told you that when I will do the project I will import the libraries. Right, matplotlib inline that is required for visualization and import matplotlib dot pyplot as plt and import cborn as SNS. Okay, these two are visualization library. That means we can create different kind of graphs using those libraries. Okay. Now this one means that I want a figure that will have a 6 size. Okay. Now write plot dot title. Title means I'll give a name to the figure like detecting outliers. Fine. Uh, if you want, you can give font size equal to 12. Fine. Now do the box plot. SNS dot box plot x equals to df. What is the column here? The column name. The column name is number. No, sorry. The column name is time spent company. Fine. Now let me run this one. Box plot, not PLT. Okay. See, we can see these are the outliers. So now let's check how many outliers are present in our data. Okay. Now we will write like percentile 25 equals to df time spent company dot quantile 0.25. Fine. So it will give us the 25th percentile. I hope you know percentile. That is a part of the statistics. You have to know, otherwise it is not possible for you to understand. It's like you are dividing the data into four parts. Starting from 0, 25th percentile, 50th percentile, 75th percentile, then 100 percentile. Okay. So it is just dividing the data set into four parts. Okay. But you have to know this. If you don't know, then you can let me know in comment section. I'll make a video for that. Now I want the uh, difference like equal to percentile 75 minus percentile 25. Okay, so it will give me the difference. Now I want, now how can I distinguish the outlier? I'll make an upper limit for my dataset and a lower limit for my dataset. So whichever data are above the upper limit or below the lower limit are known as outliers. Okay. Now suppose I write upper limit equals to percentile plus 1.5 into IQR. That means the difference will be multiplied with IQR and that will be added with, this one means it will be added with 75 percentile. So if you add the 75 percentile with this, then you will get the upper limit. So that is the maximum you are considering. Any data above that upper limit is considered as an outlier. Next one is lower limit. Lower limit equal to percentile 25 minus 1.5 into IQR. Same, you are just getting the lower limit. That will be below percentile 22. Up to this limit, you are considering the data. Now let's print them. Print upper limit, print lower limit. Fine. So you can understand the average. How did that happen? Oh, I'm so sorry. Here you have to go with the 75th percentile. I want the 75th percentile. I wrote it 0.25. Now let's check it. Now you can see that upper limit is 5.5. That means maximum people are staying for 5.5 years and minimum they are living in 1.5. If there is anything extreme, like someone has left within 1 year or someone has worked for more than 6 years, so these are known as outliers. Okay. Now let's see how many outliers are present in our data set. Now for this I will write DF time spent company greater than upper limit. Those who are greater than upper limit are outliers, and as I said, those same time spent company less than lower limit are also outliers. You get my point? This is in a bracket. This is for lower limit and give them in DF. Fine. See, these are the outliers. Let's check. Time spent. They have retained for 6 years. They are for 10 years. Oh, there are so many outliers. Okay. Now keep them in an outliers. Fine. Now let's check the count. So it will give us the number. See, there are 824 outliers. Okay, 824 people are kind of exceptional. Okay, fine. Now let's check other columns. See, what are the other columns? Average monthly hours, number of project. Now let's see that what is the relationship of average monthly hours, number of project with how many have left or how many have resigned. Okay, for that first I can create a box plot. So SNS dot box plot. Now you have learned data equals to DF, x equals to uh, average monthly hours. So it will be average monthly hours, y equals to number project number project, and q equals to left. Fine. Okay, give it a horizontal orient. Orient equals to h. Now see the box plot is created. 0, this means they have not left, they have left. Here you can see those who have worked for 250 to 300 hours all left. Worked for 7 projects all left. Here also people have left who have worked for more hours. They have stayed. Here maximum people have stayed. The average works 150 to 250. Average project, number of project 5. Here number of project 4. This is also a good symbol. Here also people have stayed but people have left also. So 4, 5, 6. I can not 6 for 4, 5. So 4, 5 kind of optimum. 3 is also okay. But in 2 projects, who have worked in 2 projects also have left. But who have worked in 7, maximum left. Who have worked for more number of hours, maximum left. Here also left. Here also more number of works kind of left. Okay. So this is the average hour an employee should work for staying in the company. 150 to 250 and kind of 4 to 5 projects. Okay. Let's check one more histogram. SNS dot hist plot data equals to df, x equals to number project. Now let's see. Okay, so you can see 2 3 4 5 6 7. It is showing us the number of project. Now we have to check how many have left and how many have retained. So u equals to left. So there it will create a Q for this also. See here, left 0, that means not left, this one left. But these are overlapping. Okay, make them distinct by giving multiple equals to dodge. Now see, it will create a distinct. Okay, fine. It is looking fine now. See, those who have worked in two projects left. Two projects are unable to satisfy an employee. Three projects, they are highly satisfied. Very rare left. Four projects, highly satisfied. Five project is also good. So we can say three, four, five are fine. But six, this is also not so good, and seven means everyone has left. Okay. So nobody will work in seven projects. But three to five are good. So from here also we have kind of derived the same. And here also we have got a good point. So how many number of works and how many projects an employee should do so that the employee stays in the company. Fine. Now we can check how many people have worked in seven projects and have left the company. We can check that. Okay. First, let me write df number project equals to 7. Then we will get that how many people have worked in 7 projects. So it is giving me the boolean value for all the rows. Okay, first show me the output. So df 7. Okay, this is showing me the data set. Now I want them who have left. Only those who are left is 1. So this many. Okay. But I want the number of count. So I can write value counts. So it will give me the count. See, 145. So 145 people have left. Okay. They have worked in 7 projects. 155 people have worked in 7 projects, have left. So write the steps we have done for the day. We have done all these things like deleted the duplicated values. Then we have checked outliers. Next we have created visualized the relationship between monthly works with number of project. Okay, what is our conclusion right now? That the optimal number of project is between 3 to 5. Second, those who have worked more than 250 hours, that was 250 hours, right? Have left. Third, those who have worked in 7 projects have all left. Okay, so these are the things we have got till now. Okay, we will do more analysis and visualization in our next class. Till then, bye, happy learning. Hey everyone, let's resume our project. Now we can check what are the other things we can experiment. Okay, first let me download the dataset again. Okay, we have already worked with this column and average monthly hours, number of project. Now we can uh, check the satisfaction level with average monthly hours. Okay, let's do a scatter plot. SNS scatter plot data equals to df. That means the data set is df. X is the x column where we can write average. This one will be in the x, comma y. We want to check satisfaction level. Okay, so this one can be satisfaction level. Next, given hue that is on left, whether they have left or stayed. Okay, now let's see. Okay, 1 minute. Let's give alpha equals to 0.4. Now let's check. So we can check that those who have worked for 250 to 300, they have left. See, this one left. But they have remained like 150 to 250 hours. Not 250 because here 230 or we can say. So 200 to 230 is kind of an optimum where nobody has left and the satisfaction level is uh, we can say 0.6 to 0.9 because at satisfaction level 0.2 to 0.4 some people have left. Here also some people have left. Those who have worked for these long hours, 250 to 300, they have a very lower level of satisfaction. That is kind of logical. If you work too much, you must have lower level of satisfaction. And they have almost left. More than 300 hours, all left. Here also we can see that some people have left. They have worked for more number of hours. Though their satisfaction level is high. See here, the satisfaction level is high, but still they have left because they have worked so much. They have worked many number of hours. So this is the kind of optimum place where it is like 150 to 230 we can say, and the satisfaction level is kind of 0.6 to 0.9. Okay, so this one we can derive from this graph. So we can write that those who have worked for 240 hours monthly and more has all left and have a very lower level of satisfaction mostly, right? Number 5, mm, satisfaction level with 0.7 to 0.9 and have worked for more not more between 150 to 230 have retained, have stayed in the um, organization or company. Okay, that is fine. Okay, now let's see what are the other things we can check. df dot head. The more you plot graphs, the more you try to explore the data, the more you will be able to know about them. Okay, because these data will help you to know that whether an employee will stay in the company or will leave the company. Accordingly, you can take measurements to improve so that they stay. Okay, now see here what are the other things we can do. Now check satisfaction level with time spent. Okay, see. So we can create a box plot. SNS dot box plot data equals to df x equals to satisfaction level, comma y equals to time spent company. You can rename it to something smaller also. That will be better in fact. Q equals to left and given horizontal orientation. Okay, now let me see. See here. Mm, higher level of satisfaction have not left. Time spent 8 years, high level of satisfaction has not left. Time spent 7 years, good satisfaction level, not left. 6 years, some have left with good satisfaction also. Okay. 5 years, some people have left. But 4 years, 4 years, with lower level of satisfaction has left. See, those who have worked 4 years but with a lower level of satisfaction, people have left. Here also, in second year also, maximum people have left. Okay. Okay, now let's take another histogram. SNS dot hist plot data equals to df x equal to time spent company and u equals to left multiple equals to dodge. Okay, now let's see here. Okay, this is 1 minute. Shrink equals to 5. Now see, now it's looking good. So you can see that mm, at the second year, people maximum has remained. Fourth year, people have started leaving. It also left. Sixth year, 18. Okay, when they have reached 18, there are few employees, but they have remained. Okay, so second year is also fine. New employees are also not leaving. But fourth year, this is third year and fourth year, kind of employees are leaving. Right, fifth year also, they are leaving. But at least here some more people have stayed. But in this 2 years, 4 years and 5 years, maximum people have left. But they have remained. Maybe they have stayed for a long time. They are adapted with the organization and environment. Okay. So we can write a point from here. Like we can say that those who have worked for more than 7 years have stayed in the company. Fine. Next, uh, next we have seen that this year 4, 5, fourth year and fifth year. Here also see fourth year some people have lower satisfaction level. Okay, so we can write those working after 4 years in the company sorry having a lower satisfaction level has left the company. So, measurement can be taken when employees are kind of completing 4 years so that some incentive can be provided to them so that they stay in the company. Their satisfaction level needs to be improved. Okay, okay, fine. Let's see what are the other things we can explore. See the data set again. So, we have kind of worked with satisfaction level, with time spent company. You can check with different kind of combinations. All our motive is to find the hidden patterns, like why they are leaving. Now let's see in which department they are working. Okay, so we can write DA department department dot value counts. It will provide us that how many people are living in which department. See here, they are working in sales, they are working in technical support, IT. Okay, there are many departments. Let's create one more histogram. SNS dot hist plot data equals to df x equals to department q equals to left discrete equals to 1 u order equals to 0 comma 1 and multiple equals to log. See what is the output. They are overlapping. Then we can write plot dot x ticks rotation equals to 45. Now see. Okay, now it's visible. Okay, give one more thing like shrink equals to 0.5. Now let's see. Uh, Nothing we can actually conclude from here because in every department some people have stayed and some have left. But in sales, maximum people have stayed there actually. Uh, Nothing can be derivable. Okay, no problem. Let's check something else. What are the other things we can explore? See here. Last evaluation, project, monthly hours. One thing we can do that is checking the satisfaction level by group by also like df dot group by and I'll group by on left. I'll group by on left, then on satisfaction level dot aggregate np dot mean comma np dot median. Now see. So here what it does, we are grouping by on satisfaction level and creating the aggregation value. Mean aggregation, this one, median aggregation, this one. Okay. So we can say that those who have left has a satisfaction level of 66%, median 69. Those who have those who have stayed for them, those who have left, satisfaction level is low. Median also satisfaction level is low. That is right. Okay. Obviously, those who have more satisfaction has remained. Those who have less have left. That is fine. Okay. So we have kind of explored many things, and in our next class, we will try to apply the model on this class so that we can predict whether in future a an employee will stay in the company or leave the company. Okay. Bye. Happy learning. Hello everyone, welcome back. So we have completed the EDA part almost. Now we will do one more heat map and then we will start modeling. Okay, now let's do the heat map. HNS because the heat map is in Seaborn library. So heat map. Now write df df dot correlation that will create a correlation between all the columns and I want to give it a range like -1 to max equals to 1, then cannot equals to true. It will show the number, so it will be good for visualization understanding purpose. And I'll give cmap equals to sns dot color palette. Give we like this is a color palette. Okay. Okay, there is this is a string, so on string you cannot apply correlation. So I have to take the numeric values, the numeric columns. Okay, so I can create numeric data frame equals to df dot select d types include only those which are number. Fine. Now I have to make change here also numeric underscore df. So I am applying on uh, include equals to number. Now see, not color, it's color. So many mistakes. No problem. We have got it. Okay, we can make the figure big. Plot dot figure fig size fig size 16 comma 9 size equals to. Okay, so fine. So we can say that uh, This is negatively correlated. That means satisfaction level with left. Okay, that is negatively correlated. All others are almost positive. Same here. 1 means highly correlated, minus 1 means not correlated. Okay. So we can say that satisfaction level with left is not correlated. Okay. Negatively correlated. Okay. Okay, fine. Now let's do the modeling part. So let's check the column once again. And what is our aim right now? Our aim is to find whether the employee will stay in the company or leave the company. So left is our output. All other columns will be our input and model will give us the output, which is whether left is 0 or 1. Fine. So we can say that the output is a categorical variable. For categorical variable, logistic regression is kind of perfect. So we will apply here logistic regression. Fine. Now see here, before modeling, we have to change all these columns into only numerical columns because machine learning only understand numerics. So if there is any column which is containing string object, we have to convert. So how can we do it? By many techniques, but here I will apply the get dummies one. Okay, let me do it. So you can write df equals to pd dot dummies df comma prefix equals to give some name like salary is fine, then department is also fine, comma column salary department draw first equals to false. It is saved in df. Let's check first. Df dot head. Here you can see it is showing like this. Okay, fine. Now you remember that there were outliers, almost 8 to 4 outliers. So we have to remove this because without removing, if we try to model, then it may show us anything bias output. So we have to remove the outliers because logistic regression model is very much sensitive to outliers. Fine. See here this one, 8 to 4 outliers. Okay, so we have to remove all the outliers. Now before that, just check how many rows and columns we have. df dot shape. Okay, I have to remove the outliers only. So I can write df time spent company greater than equals to lower limit. And so this will not be or, instead will be and it is less than equals to upper limit. Fine. Now see, 11,167 columns. We had 824 outliers. So this is fine. Okay. So now I will keep it in df to make it a permanent. Okay. So now df is fine. Now I can write df dot head. Just check if everything is okay. Everything is okay. Fine. Now let's do one thing. Now I have to apply the model. Now I have to apply the model. So I have to divide the dataset into training part, into testing part. So I will write x equals to df, x equals to df dot drop columns equals to left, y equals to df left. Let's see what is in x, what is in y. So x is considering every column other than the left column. Okay. Now y must be the left column. Just check it. Y will contain the left. Okay. So we have divided into x and y. Now we will do the train test play. Now write x train, x test, y train, y test equals to train test split x comma y comma test size you can give as per your wish, but I will give 0.2. That means 80% of the data will be used for training and 20% will be used for testing. Fine. Random state equals to 42. Now see here, I have to import one library. So we have to write from sklearn dot model selection import trend test split. Fine. So we have to import those libraries to apply those functions. Now see here it is fine. So we can run it. Okay, I forgot to run that. I'm very sorry. I have to run it. Now we can run it here. Okay. We will create the model. So we can write model equals to, we will apply logistic regression model. Okay. If you don't know logistic regression, you will not be able to understand how it works. So you have to know the theory. Hey, I'm sure you know random state equals to, I'm starting from 42. You can give any number. That means so that the output doesn't change every time I change it. Okay, that's why. Max iterable equals to 500. And I will also do it fit extend, comma, y10. Okay. So I will apply logistic regression model. This is because so that output doesn't differ every time, and max iteration is 500. That means model will be trained on the data set for 500 times, and this is like fitting the extend and y10. Now why it is because it is in capital letter. Fine, and is fine. But logistic regression means I have to import. So now import from sklearn dot linear model import logistic regression. Fine. Okay. Let me run this one. Fine. Now, now I think it will work. This is fine. Now write y pred equals to model dot predict exist. If test, oh, I'm sorry, I have make it capital. That's why this is creating a problem. So now, so what is y pred? Y pred is the result we are getting from the model. Okay, let me tell you the whole picture. Suppose there is a data set containing 10 rows. Now what I have done, I have divided it into 80-20. See here 0.2. That means 8 rows will be used for training purpose, 2 rows will be used for testing purpose. Now in the next line, left the 2 rows, and on that 8 rows, I have input output. So model is trained. Model has understood the pattern. Model has understood what will be the output when we give the inputs. Okay. So now model has found the pattern. Which model? We have applied logistic regression model. Now in the next line, I will take only those 2 rows which are left for testing on which model is not applied. Now on those 2 rows, I will apply the model to check what is the output value. So y pred is that output value. Fine. Now we have real output value of those 2 rows, that is y test. Those are the real values. But y pred means here the model who have just learned how to predict has predicted something of its own. So now our job is to compare these two things, the real value and the predicted values. Now see how can we do it? By using a confusion matrix. Okay, now let's create a confusion matrix. CM equal to confusion matrix y test y grade labels equal to model dot classes. Fine. Now display confusion matrix display. Fine. Now confusion underscore matrix equals to cm comma display labels equals to model dot classes. Fine. Now this dot plot. Now see what happens. Okay. So now I have to import all the libraries. Okay. Now see here, I'll write the things I need for now. From sklearn dot matrix import, I'll be needing accuracy score, next precision score, next recall score, next F1 score, next confusion matrix, next confusion matrix display, next classification report. Classification, sorry, classification report. Fine. Now let's go down. Now see what happens. Confusion matrix is not defined. Why is that so? Okay, this will be confusion matrix underscore. Fine. So this one is confusion matrix. Okay. Now you can see the confusion matrix. If you don't know, let me tell you. This means true negative. This one is false positive. This one is false negative, and this one is true positive. Now this one, like true negative. True negative means these are the those employees who did not leave, and model also predicted that they will not leave. Okay, fine. But these are the people who did not leave, but the model predicted that they will leave. Okay, so wrong prediction. Here, what about 286? So 286 people left the company, but the model was unable to predict. So model unsuccessful here also. Now what about this one? 102. These are true positive. That means the model predicted that they will leave and they left the company. So here also model predicted correctly. Here also model predicted correctly. Model predicted they will not leave. They did not leave. Model predicted they will leave and they left. Okay. And these are opposite. What model predicted and what actually happened is not same. Fine. So this is what confusion matrix tells us. Now let's do one last thing, that is printing the classification report. For that, suppose write target names equals to will live and will not live. Fine. Now write print classification report y test y pred target names equals to target name. Fine. Now see here, uh, this is the precision value, recall value, F1 score value. So you can see that uh, 0.83 accuracy, the logistic regression has model achieved. So precision 0.86, recall 0.94. This is the precision value. Okay, so we have almost completed our project. Now if you want, you can decorate it like doing more visualization or different kind of experiments in your EDA part, and also applying other types of model, like you can apply decision tree classifier and check its accuracy. Okay, and what are the other things we can do? It's like you can decorate this just like giving a title or giving a proper font size. So these things you can do, or you can write the comments like we have already done something, and all other things here, just like importing the libraries, importing the data set, checking the first 10 values, save info. This is describing the statistics of the data set. So this way you can create a complete project. Okay, and you can upload this whole project in your GitHub. I already made a video like how to upload the folders or files in your GitHub account using Git Bash, as well as uh, directly. If you want, you can just create an account and directly upload the folder also. Bye. Happy learning. Hello everyone. Welcome back to this channel. We have already completed this project. We have done every step. Now in this video, I'll just summarize the whole thing we have done. Okay. It's a complete project and we will just revise the whole things. Okay, what was our aim? Our aim was that we have to find whether an employee will leave the company or stay in the company, depending on some given factors. We had this data set and there are some columns you can see. So depending on these factors, the employee may stay in the company or may leave the company. And our job is to predict so that the HR can take some measures so that the employee stays. Okay. Now, how we did the project? We used logistic regression model. Why? Because the output is a categorical variable, either 1 or 0. Will stay or will not stay. That's why we used uh, logistic regression model. Okay, first what we have done, we have imported all the libraries. These are necessary because we will be calling many functions which are described in these libraries. Okay, next this is used pandas pd. You can see pd is used to just upload the data set. You have a data set which is containing all these values, so we have to upload this data set so that we can work on that. Head function is used to show us the top rows. If you want 5, then you can write 5. If you want 6, you can write 6. By default it is 5, otherwise you can fetch all the rows you want to fetch. Okay, in the next step we checked df.save. That means it just gives us the rows and columns. In the dataset there are almost 14,900, not almost 14,990 rows and 10 columns. Okay, you can count from here 10 columns also. Fine. And one more thing, that we have a CSV, but if you want you can just convert it into XLS and you can open it in Excel file. That also we did. This is mainly CSV file because all the values are separated by comma. Okay. Next, info function. Info function provides us the information of the column. See, this is the first column, second column, third column. Now here you can see that what is the type, like it is a float, it is also a float. These are integers, department and salary is object, like this. See, so you can get an overall information from the info function. Then we used df.describe. Describe gives us the statistics of the dataset. Here just like count, mean, standard deviation, minimum, percentile, 25th percentile, 50th percentile, 75th percentile, what is the maximum value. Okay, count means total count, mean means mean of the total column, standard deviation means deviation from the average value, minimum is the what is the minimum value, 25 percentile means 25% of the data set is below this number. Same way 50% of data, 75% of data. Okay. So this gives us the statistics of all the numerical columns. Okay. Next, we have just check what are the column names. If you find anything wrong, any misspelling, then just you can rename them. That means rename function you can use so that you can rename them and correct the columns. Okay. You can give some shorter columns also or something more appropriate. Okay, fine. Next is how we have to check whether there is anything missing value. So we can write df.ijna.sum. This here, as we can see that there is no missing values. If there is, we have to either delete the missing values or we have to replace them. Okay. In the next, we have checked whether there is any duplicated values. The same data, because the data is not always clean, na? So our job is to perform the data cleaning. Here we are just doing the data cleaning process. So we have checked if there is, obviously you have to delete because you don't know, you don't need duplicated values. Keep equal to first means the only one value will be kept and all other duplicates will be deleted. We have rechecked it here and we have just fetched the some rows to check whether it is okay or not. Then we have detected the outliers. Why outliers? Because outliers are the far from the average and it will create bias if it exists in the dataset. That's why we have just tried to create a figure. This is a box plot. Okay. This is done using Seaborn. And here we have detected the outliers. Fine. Why we have detected the outliers? Because we want to remove them. Otherwise, our model will not work perfectly. Later on, we have removed them. Here we have just checked the shape again. That means columns, rows, because duplicates are deleted. So you can see that rows values are deleted. This one is row and this one is column. Next, this is the outlier. What is the then? We have to decide what is the upper limit for the outlier, what is the lower limit for the outlier. And we have done it using the percentile things, 25 percentile, 50 percentile, 75%. A data set is divided into 4 parts. So first we have taken 25th percentile and 75th percentile. And then we have calculated some upper limit and lower limit. And we want the data set only those values from the dataset which are within these limits. Outside of upper limit or outside of lower limit will be removed. So outliers will be simply removed because we want the average part, we want the concentrated part. Okay. Next, we have seen that there are 824 outliers. Fine. Next, we have just checked what are the relationship between different kind of columns. This is a kind of experiment you can do, like any types of experiment, whatever you think as per your judgment that these columns may be connected somehow. You just plot them and check whether they are connected and how they are exactly working. Okay, here like we checked box plot. This one is histogram. If you want, you can make this figure size big also, like this. Here we did plot dot figure fixed size. You can change it. You can make it bigger. Okay, that is fine. Next we saw that number of projects who have done more than 7 project has left. So we have just worked with all these data set. Next we have done a scatter plot. See here with two columns, average monthly hours with satisfaction level to check how both are kind of related. Okay. And you can draw conclusions from them. You can find the hidden patterns which can be used for employee retention. Next, we have created a box plot as well, histogram with other columns, and in which departments people are working, how many people. There also we have created his plot, but we didn't find something special from here. But you have to check multiple times with multiple things so that you can find the patterns. Okay. This way you can get the value of mean, median. We have done loads of EDA in this project. Okay. Here also we have created a correlation map. Correlation, how they are correlated. Like this means positively correlated. See the color also, color pattern. You can check the color pattern. When it is going to -1, this is negatively correlated. So correlation is going down towards downside. Fine. We can find the patterns, how they are related. What is the satisfaction level if someone is working for more than 5 hours or 5 years or more than that. Then here we have just removed the outliers, and then we have splitted the data because the data set, you have to split the data set. On some part you are going to apply the training, and on other parts you are going to apply the test data set. So here I have first make it x and y in the x column. Sorry, in the x dataset I have kept all the columns. In the y dataset I have kept the left column. Left is the output, that is what we are going to check. Okay, fine. And one thing I forgot to tell you, here we have done one hot encoding because department and salary, you can see these are objects, all others are numerics. So our job is to change them to numerical value. That's why we have done get dummies. Okay, so here they are changed to numerical. False true means they are 0 1 types because it's boolean value. Fine. Now here we have checked x and y. These are fine. Next we have to do trend test split. That means the data set will be divided into 80-20 parts. 80-20 why? Because I have given 0.2. If you give 0.1 then it will be 90-10. If you give 0.3 then it will be 70-30. Okay. Random state, you can give it any number, but I have given 42 because this is kind of tradition. Okay. So after trend test split, the data will be splitted, and on 80% of the data, the model will be trained. Their model has both the input value, the output value, and model is trying to find the relationship between input and output. Fine. So after it finds the relationship, then it will be applied on the test data set. Okay. So the whole data set is not trained. Fine. Train test split just splits the data set because only 80% of the data it will be applied. Next, model equal to logistic regression model we have applied. Maximum iteration you can give anything and you have to fit it because, and fit means the model is actually trained here. That means it is trying to find the gradient descent, the pattern, how input output is fitted. Okay, so the model is trained here. Next, once it is trained, it will predict. Predict on which? Predict on those data sets which have been not trained. Those 20 data sets. X test 20% of the data set model will predict. Model has trained here. Now model will predict, and that will be kept in a different variable. Okay. But those data set we also have some values like whether the employee has left or employee has stayed. We have that y test value. Now the model has predicted y pred value. So we have two values. Now we will check whether those values are equal or different. So here we have plotted a confusion matrix. Here the model predicted the employees will not leave the company and the employees didn't leave the company. And here the model predicted that the companies will leave and the employees left. So in two cases, the model predicted what is correct. But here in those cases, the model predicted wrong. The model predicted something, actually happened something else. Okay, so these are known as precision, recall, accuracy. If you don't know, you have to study all these things. I hope you know. So we have just applied confusion matrix to check what is the kind of accuracy the model is providing. And finally, we have printed the classification report. Classification report will give us the precision value, recall value, F1 score value, and you can see that we have achieved 83% accuracy. This accuracy can be improved, and we can do this thing using other algorithm also. Okay, so in this video, I have just tried to revise all the things, and now I will update all these things and I will upload it in GitHub and will give you the link also. Okay, so bye, happy learning.